Good morning, everyone. I am Abitha, working as an assistant professor in the Department of Artificial Intelligence and Data Science in Tech Multitech, Dr. Rangarajan and Dr. Shakuntala Engineering College. Today, we are going to take a video lecture on cloud computing subject. What is cloud computing? Cloud computing is the delivery of computing service like storage, server, and software over the internet on a pay-as-you-go basis. What are the cloud providers? Cloud providers like Google, Amazon Web Service, Windows Azure. Cloud computing can be used to handle demand and demand services. You can use resource anytime you need, and that is the pay as you go. You only pay for what you use, and it is easy to accessibility. Can be used anywhere with the internet connection. We use the cloud storage for the service provider in the cloud computing. We are discussing about the overview for the cloud computing, like fundamental cloud architecture, advanced cloud architecture, and specialized cloud architecture. What are the applications of cloud applications like monitoring, content, collaboration, communication, finance? We are using so many applications to the cloud. Like we are using the virtual clouds to perform what service like infrastructure as a service, platform as a service, software as a service, like the object storage, identity, and runtime queue database. We store every data in the system like we store in the cloud. Fundamental cloud architecture. What is fundamental cloud architecture? The architecture of cloud computing contains many different components. It includes client infrastructure, application, service, runtime clouds, storage space, management, and security. That is the shown in the figure. Here, the architecture for cloud computing is the front end and back end. What is front end? The part used you see and interact with the web or website or a app. It is the front end. What is the backend? It is a backend is the hidden part of the work in the background to process data. Example, database, server, and logics that make the website actually work in the backend process of the brain of the application in the process. The cloud architecture, cloud computing contains the client infrastructure. It connects to the internet, and the internet connects to the application, a server, runtime cloud, and storage and infrastructure, management and security. So backend contains the application, server, runtime, cloud, and storage, infrastructure, security management. Front end contains only the internet and client infrastructure to store our data in the cloud storage. What is a front end? The client uses the front end, which contains a client side interface and application. The front end includes web server like Chrome, Firefox, Opera, etc. Client and mobile device. And what is backend? The backend part helps to manage all the resources needed for cloud computing services. This includes a security mechanism to large amount of data storage, a server, virtual machines, a traffic mechanism of the cloud. When the cloud service provides the cloud-based functions like storage, computer database, and runtime cloud contains the environment where cloud applications run. The storage can store user data and files in the cloud. Example, Google Drive. What are the important components of cloud computing architecture? First one is client infrastructure. Client infrastructure is a front-end component that provides the geographical user interface. It helps user to interact with the cloud. Example, the user device like laptop, phone used to access the cloud. Next one is application. The application can be any software or a platform which a client wants to access like Gmail, Zoom. It's the actual software for the applications. Next, service. The service component manages which type of service that can need according to the client requirements. Like what are the services like software as a service, platform as a service, and infrastructure as a service. Next, infrastructure as a service. What is infrastructure as a service? Basics, server, service, user maintained software, user control, OS data application. What is infrastructure? You rent the infrastructure instead of buying it. Example, Amazon EC2, Windows Azure, Google Compute Engine. These are the infrastructure as a service. It provides a virtual hardware resource like a server, storage, and networking over the internet, like Amazon Web Server, AWS EC2. It's a virtual server for running apps. Next one is Microsoft Azure Virtual Machine and cloud-based computer. Next one is Google Computer Engine. GEC, virtual machine on Google Cloud. And next one is a digital ocean droplets, a simple virtual server, infrastructure as a server, renting online service and storage instead of owning physical server. And next one is platform as a service. What is platform as a service? User are given software and hardware automatically. User control applications data. It provides a ready-made platform with a tools, framework, and runtime to build, test, and run application without worrying about the server and the hardware. Example, Windows Azure, Force.com, Google App Engine, Apache Strategies, and Microsoft Azure App Services. What is Google App Engine? Lets you deploy apps directly, and Microsoft Azure can build and host web Marks. Next one is a Red Host OpenShift as a cloud platform for the development. Next, software as a service. What is a software as a service? All software and hardware is a transparent. User only knows the own access point. Example, Google Apps, Microsoft 365. Next to Google Drive and Gmail using the email service online, and Google Cloud storage service. It provides a ready to use a software application over the internet without installing anything. This is the architecture diagram for the fundamental cloud architecture. Fundamental cloud architecture contains a private cloud, infrastructure as a service, and platform as a service, and software as a service. Private cloud contains is a consumer process. Consumer can have the application data, OS, virtualization, server, storage, and networking. What infrastructure as a service have is customer have a application data and OS. A provider can provide the virtualization, server, storage, networking. Next, the platform as a service. Customers have application and data only. And provider can provide the OS, virtualization, server, storage, and networking. Software as a service. A provider is only giving the all the software requirements to the clients like application, data, OS, virtualization, server, networking, everything will be provide as the software as a service in the cloud computing storage process. It is the fundamental cloud architecture for the simple diagram for the all the three services. Next layer is the runtime cloud. Runtime cloud offers the execution and runtime and the virtualization. Final one is next storage. Storage is the another important cloud computing architecture concept. It provides large amount of storage capacity to the cloud to store and manage data from the customers. Last one is infrastructure. What is infrastructure? Infrastructure is given by the offer services to the host level and network level of the application levels. Cloud infrastructure includes both hardware and software components like a server, storage, network, and virtualization software, and various other storage resources needed to support the cloud computing model. It's the infrastructure to provide services, all the services in the virtual basis of the cloud. What is management? This company manages components like applications, servers, a runtime cloud storage infrastructure, and other security matters in the backend process. Backend process can manage all the management process of the like applications and servers runtime in the cloud storages. It establishes connect between them. And next one is a security. It is also the backend process of the service like a cloud. Security is the backend representing different security mechanism for secure cloud systems like resource files and infrastructure to the end user to get the all the data to secure in the security process. Next one is internet. Internet connection is the act to bridge medium between the front end and back end. It allows to interact, it allows to establish the interaction and communication from the back end and front end process to interconnect to the internet is the main resource to connect all the softwares like hardware and our software to the application to maintain all the clouds and the security in the cloud storage. Next, fundamental cloud architecture models. Each model representing a each model representing a common usage and characteristics of current cloud-based environments. What are the current cloud-based environments are? Cloud architectures like workload distribution architecture is the spread the task across server to avoid overload. And next one is resource pooling architecture. What is a resource pooling architecture? Shares a resource among multiple users to share the data in the resource pooling. Next one is dynamic scalability architecture. What is dynamic scalability architecture? It adjusts resource automatically with the demand. If the client can access the so many persons to want to access the scalable, it will adjust the resource automatically with the demand. Next one is elastic resource capacity architecture. Resource with the expands or shrinks a resource as a need. What are the need? If the client needs more cloud service storage, it will give the need to access. If you one or two many needed services to access for this one client. Next one is a service load balancing. Service load balancing is the distributed traffic eventually among the service. It can load all the services across the clients to access data and service eventually to the services. Next one is cloud bursting architecture. I switch to public cloud and to the private cloud and the full. If some people can access public clouds in the like Amazon and Google is the public cloud. Is the private cloud is the in some large organization is access the private cloud. Some people can access to public to private is possible if they can access to pay the cost per of the solutions. Next one is the elastic disk provisioning. It provides a storage space dynamically to the client to access all the storage of the architecture. Last one is redundant storage architecture. Redundant storage architecture, it can store multiple copies of data in the safety concerns to process it various location and various cloud to store all the data in the storage of the architecture. This is the workload distribution architecture. Information technology resource can be horizontally scaled by the addition of one or more identical IT resource, like the resulting of the spreads task across a server to avoid overload. It avoid the overload of the too many clients to access runtime logical to the distributing of the workload among the IT resource. If you are resulting workload distribution architecture, both IT resource and some other private clouds under the specialized of the load balancing process. This is the architecture diagram for workload distribution. If you go to the cloud service consumer, the cloud service consumer go to the load balancer and cloud service A and cloud service B can provide the virtual server of the both servers in the interpreter service request to the consumer to provide the virtual service and the work in the cloud process. Next topic, advanced cloud architecture. The advanced cloud architecture models contains so many architectures too. Next step is the first one is hypervisor clustering architecture. Second one is load balanced virtual server instance architecture. Third one is non-descriptive service relocation architecture. Fourth one is a zero downtime architecture. Next one is cloud balancing architecture. Resource the reservation architecture, dynamic failure detection and recovery architecture. Next one is bare metal provisioning architecture. Next one is rapid provisioning architecture. Next one, the final one is storage workload management architecture. We are advanced cloud architecture. Like first we go to see that what is hypervisor clustering architecture. What is hypervisor clustering architecture? Hypervisor clustering architecture is the group hypervisors together for high availability and resource sharing. It can share the resource in the virtual machine mechanism and monitoring to the virtualization process of the multiple OS to share a single hardware host. Hypervisor cluster architecture established and controlled by the centralized virtual infrastructure manager like VIM. Another one is virtual machine. Next one is VMware. Regular heartbeat message to the hypervisor confirmed with the message running. The heartbeat message that are not successfully acknowledged, the VM led to initiate the live virtual machine migration program in order to be dynamically move effect to the virtual server of the new host. If the hypervisor cluster utilizes shared cloud storage devices, in 1 to 4 provides get example result to the hypervisor patterns accompanied by the number. This is the hypervisor clustering architecture. What is hypervisor clustering architecture? It groups the hypervisors together for high availability and resource sharing. Like virtual server, it contains so many virtual servers. If one or two virtual servers can connect with the hypervisors can connect with the multiple physical servers. The physical servers can directly connect to the virtual machines. The virtual machines can connect all the messages to pass in the server to like heartbeat messages, heartbeat like structure to the processor, message to the count message of the process in the hypervisor clustering architecture. This is the another one architecture diagram for hypervisor clustering architecture. It is the main database contains the virtual servers like virtual server A, B, C, D, and E. It connects to the hypervisor and then hypervisors connect to the physical servers. So the physical servers can connect to the one physical server to another one in the virtual infrastructure management. All of the virtual servers and physical server and hypervisors are connected with the virtual infrastructure manager. Virtual infrastructure manager is the software layer that manages virtualized resources like compute storage and network in the cloud environment. In the connections can be together in the like heartbeat and hypervisors. It can increase and decrease the range between the physical servers of the hypervisor clusters like in the architecture. When the hypervisor cluster architecture can disconnect to the virtual server to the hypervisor, it will be occurred in the physical server can fail to connect to the multiple servers in the storage to virtualize the infrastructure to applications of the manager to it will decrypt to the process in the network connections in the virtual manager machines. The hypervisor cluster architecture controls and allocate virtual resources in the cloud infrastructure like OpenStack, now and VMware in the centers. This is the final hypervisor clustering architecture. When the hypervisor clusters can connect with the live VM migration, if the server can actually automatically connect to the virtualized migrations in one data storage to the another server to virtually connect to all that. If one system is failed to access data, it automatically connect to another system to generate the data in the different locations. So like physical servers and physical servers connect to the virtual servers and virtual servers and physical server connect to the hypervisors. It can combine all the servers in hypervisor physically and the physical servers like virtual and physical server in the virtual infrastructure manager in the migration process of the one server to another server in the VM migration process in the hypervisor clustering architecture. This is the steps to describing the hypervisors, how hypervisors are installed on the three physical server and virtual servers can create the hypervisors and share the cloud storage device containing the virtual server. Configure the file position in the hypervisor to access it. And hypervisor cluster enables the free physical servers hosting the Suntan virtualization virtual infrastructure manager like VIM. The physical server exchange a heartbeat message with each other in the VIM based on the predefined schedule. Like physical server B fails to become job predictable, virtual server C can access all the data from the physical server B to connect each other in the process of the hypervisor to sending messages in the one virtual server to another physical server. Virtual infrastructure manual machine and the other physical server stop receiving heartbeat message from physical server. Based on the available capacity of the other hypervisors in the cluster, we aim to use a physical server C as the new host to take ownership in the virtual server C. Virtual server C is live migrated to the hypervisor running on the physical server C, where it may need to be restarted before continuing to operate normally. The hypervisor clustering can one access in the virtual server A, B, C, D, and the physical servers like physical server A, B, C, D in the hypervisor to send messages, and one will be fake, another will be take care of the ownership in the physical server and the virtual server of the hypervisor clustering. What are the mechanisms in the hypervisor clustering? The cloud storage device mechanisms acts as a central repository that hosts the virtual server folder, so that the folder and virtual server configure are accessible to the hypervisor participating in the cluster. The hypervisor is the mechanism by which the patent is up, and the logical network perimeter of the mechanism creates logical boundaries that ensure that the none of hypervisors to the another cloud consumers are absolutely included in the process of the resource cluster to fundamental mechanism to create and initiate the hypervisor cluster in the mechanism. Next one is resource replication. What is a resource replication? Each hypervisor informs others in the cluster about the status and availability of the resource to share, and needs to configure or switch to create and delete or modify the virtual instance of the hypervisors by the virtual infrastructure manager. Virtual infrastructure manager can access to create and configure the hypervisor cluster and add cluster member in the cluster of the consumers to get configured in the cluster members. And virtual server. Virtual server represent the type of mechanism that is protected by the application of this pattern. The virtual switch to mechanism is used to retrieve from hypervisor failure will be access to the cloud consumer. Virtualization monitor. The mechanism is responsible for actively monitoring the hypervisors and sending alternates when the hypervisors in the clustering files to access all the data in the replication process of the hypervisor clustering architecture. Next one is the specialized cloud architecture. What is a specialized cloud architecture? Specialized cloud architecture is the advanced design model in cloud computing that is solve specific performance, storage, or networking problem by adding extra efficiency and reliability and scalability behind the basic cloud architecture. They given below the 11 specialized cloud architecture models are. First one is a direct input output access architecture. What is direct input output access architecture? A direct input output architecture allows the virtual machines to directly access hardware and hardware for uh, faster performance. Next one is a direct LUN access architecture. Let's a VMware directly access storage in the logical unit number for efficient data users. Next one is a dynamic data normalization architecture. It is the ensure data is stored and retrieved in a consistent format. Next one is elastic network capacity architecture. Elastic network capacity architecture. It expands or shrink network resource automatically on the demand changes. Next one is a cross storage device vertical tiering architecture. It moves the data across different storage device like SSD, HDD based on the usage. Next one is intra-storage device, vertical data tiering architecture. It can manage data inside a single storage device by tiering frequently used and rarely used data. Next one is a load balancer virtual switches architecture. Load balance is distributing network traffic eventually across virtual machines to virtual switches for it efficiently. Next one is a multi-path resource access architecture. Multi-path resource architectures store and serve for higher reliability of the storage space to the process in the cloud storage basis. Next one is a persistent virtual network configuration. It can keep virtual network setting interact with even after restart or failure of the data to store in the cloud. Next one is a redundant physical connection for physical server architecture. It connects a virtual server to multiple physical links to avoid downtime of the architecture in the server. Last one is a storage maintenance window architecture. Storage window maintenance architecture, it allows storage system to undergo maintenance without stopping cloud services in the specialized cloud architecture to faster and more reliable to high available of the cloud designs to make in the architecture process easily. And the storage maintenance window architecture is the prior to storage device undergoing a maintenance outage, data can be temporarily moved to the duplicate and secondary cloud storage device. When the cloud storage consumers are automatically and transfer the cloud storage device to the another of the primary cloud storage available to take in the offline. Now, live storage migration is used to convert the data as whole into the isolated mode of the secondary cloud storage device. We are using the live migration means the large scale unit number in the secondary storage device of the process. When the Luna data has been migrated, requested to data forward to the duplicate Luna's secondary storage device. This is the architecture diagram for the storage maintenance window architecture. First we connect to the live storage migration. Live storage migration is the two storages. One is primary, another one is a secondary. If the primary storage copies the data into the secondary storage, primary storage contains the temporary new path to cloud consumer data in the provided like storage service gateway. Storage service gateway can access the cloud service consumers. Another one is secondary manager. Secondary storage also can access the data from the temporarily to the consumer path data of the provided by the primary storage of the provider. If both the primary and the secondary storage can access duplicate the data in the storage to maintain the windows, separate windows to temporary to access the cloud in the process. Storage maintenance mechanisms of the cloud storage device. This is the primary mechanism to which the pattern is applied. Next one is flyover system. Although the migration is often scheduled, the pattern is applied both manually and automatically to the interpret of the cloud architecture. Next one is resource replication. It will replicate the mechanism to keep the primary and secondary storage device in the synchronized. Next, cloud characteristics. What is cloud characteristics? It contains 4 to 5 characteristics like first one is on-demand self-service, second one is broad network access, third one is a resource pooling, and fourth one is the rapid elasticity, fifth one is the measured service. This is the cloud characteristics. Next one is elasticity in cloud computing. Elasticity is the ability to grow and shrink infrastructure resource dynamically as needed to adapt to the workload changes in automatic manner, maximizing the use of resource. It's a degree to adapt the workload changes in the automatic manner of the hypervisor to create virtual machines and involve cloud infrastructure to the real-time process in the cloud storage. This is the elasticity in cloud computing diagram. We can demand will be increased, the time will be less, it will be feature associated popular, the resource to be dynamically removed when the need is accessed. They will give solution to horizontal scaling with the associated elasticity cloud. Elasticity is generally associated with private cloud resource and is more commonly featured in pay per use or pay as you grow service. In this means IT managers are not paying for more resources than they can consuming any given time. The virtualized environment cloud elasticity could include the ability to deploy new virtual machines to schedule inactive virtual machines. In additional infrastructure, it may handle the increased volume in only use. It has to grown in the lower capacity in the years of the elasticity cloud will be occupied in the IT managers in the organization. Elasticity as the scaling of system resource increase and decrease capacity, whereby defining the specifically state that the amount of provisionary in the broader sense. It can be contain manual steps, define adaptation of the process in the own does not include the temporal aspects checked before the access will be evaluated in the elasticity. Some elasticity dimensions will be processed in the types like the adaptation process. One is a resource scaling units, another one is cloud scalability covers except the predictable workload demands and handle a rapid and unpredictable changes in the scale of operations without the infrastructure and is the especially to the cloud. Next one is the on-demand provisioning. On-demand computing is the delivery model in which computing resources are made available to the user as needed. The model can develop overcome the common challenges to enterprise the being able to meet infiltration demands on the efficiently. If the entrepreneur tried to cut cost by only maintaining minimal computing to like there would not be sufficient resource to require the third party term to service the synonyms to on demand using the process in the cloud computing process to get the storage in the server like a Google and Azure to providing process in the on demand basis. This is the simple on-demand provisioning diagram to the Open Nebula and using the virtualization guest OS applications. It transfers distributed physical infrastructures to the flexible and elasticity virtual infrastructure to adapt to the changing demand in the virtual machine service workload, clustering to the extent benefits of the resource in the decoupled to the virtual machine service product physical locations and create to the distributed virtualization layers in the on-demand provisioning process of the accessing data in the cloud storage. This is the remote on-demand resource provisioning, access to cloud system and federation of cloud system. This is the remote on-demand resource provisioning diagram. It will be SGG front-end and virtualize the SGC nodes. It will be connected to the multiple physical servers and the physical servers connected to the Open Nebula and virtual managed machines to clustering nodes in the separate virtual machines to access a dedicated SDC nodes to be connect to all the system and physical and virtual servers to connect to all the demanding process of the resource to access cloud in the federation to access in the VMM. Next one is a sustainable development goals. What are the sustainable development goals are linked and matched to the cloud computing. Sustainable development goals are 17. Some SDG goals only matched to the cloud computing. What are the goals will be connected is SDG 3, good health and wealth begin. Next one is SDG 4 is the quality of education. SDG 7 is the affordable and clean energy. And 8th one is a decent work. SDG 8 is the decent work and economic growth. Next, SDG 9 is the industry innovation and infrastructure. Next one is SDG 11, sustainable cities and communities. SDG 12 is the responsible conservation and procedures productions. Another one is SDG 13, climate action. And last one is the SDG 17, partnership for the goal. Those are the sustainable development goals. First one is a good health and wealth begin. Cloud computing enables a telemedicine, health data management, and AI-driven diagnosis, improving access to the healthcare. SDG 4 is quality education. It provides the e-learning platform and Digital classroom make education more accessible globally. Next one is SDG 7, affordable and clean energy. Cloud-based energy management system optimize energy use and support renewable energy integration. Next one is SDG 8, decent work and economic growth. A cloud computing device, digital economic growth, a remote work and new business opportunities. Next one is SDG 9, industry innovation and infrastructure. Cloud cloud, it can enable smart manufacturing, IoT integration and innovation and scalable infrastructure to the infrastructure industry, and the innovation method in the cloud computing will be helped. And next one is SDG 11, sustainable cities and communities. Support smart city initiatives with the real-time data analytics, traffic optimization, and resource management. Next one is SDG 12, a responsible consumption and production. A reduce physical infrastructure needs, lower energy consumption, and optimize a resource management. Next one is SDG 13, climate action. Cloud computing reduce carbon footprint compared to on-premise data centers and support climate modeling and monitoring. It will help with the climate actions during the process of the cloud. Next one is SDG 17, partnership for the goals. A cloud platform facilitates global collaboration and data sharing and multiple stakeholders to partnership in the cloud process. Thank you.